Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Snyk. My name is Cody J. Brown, and I'll be moderating today's session. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's event is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You'll receive an email with a link to access the on-demand after the conclusion of today's seminar. We want to hear from you, so feel free to send in your questions at any time using the Q&A feature on the right side of your screen. We'll try to address as many questions as we can, so be sure to send yours in early. I'd also want to direct your attention to the chat tab. This is where you can speak with each other, speak with us, and let us know your thoughts, say a quick hello, or tell us from where you're tuning in. And finally, at the end of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. So make sure to stick around to see if you're one of our 4 lucky winners. But on to today's webinar. The topic is AWS Container Live Hack, Managing Container Vulnerabilities in Amazon ECR and Amazon EKS. And I'm joined today by Clinton Herget, Principal Solutions Architect for Snyk. It is my pleasure to turn the floor over to Clinton at this point in time. Thank you so much for being here with us today, Clinton.
Great. Thank you, Cody. So glad to be here. I am also joined by David Lugo, who is one of our partner marketing representatives at Snyk. He'll be talking to you a little bit later on today about the great partnerships that Snyk has with AWS. But as you say, Cody, the purpose of today's webinar is to show a live hack of a containerized application running on Amazon, specifically using Amazon EKS with the images stored in ECR. And then I'll be using the Snyk platform to be able to identify, prioritize, and ultimately to remediate those vulnerabilities that are found. Before we do that, I did want to talk a little bit about kind of what are the industry trends that we've seen over the past few years in terms of moving from maybe more of a legacy IT footing toward more of an application services model, and how that impacts things like the cloud and DevOps and ultimately security. Because the application services model entails a new risk profile for modern applications that ultimately doesn't necessarily correspond with the way applications were traditionally secured. What's really needed for cloud native applications, for the modern development environment, is a new security paradigm and a new way to build applications securely across your AWS stack. So we'll talk about some of the ways that Snyk is enabling cloud native developers to do that. Finally, we'll get on with the demo. We'll show a live hack of a containerized workload, again, that I have hosted in AWS. And then we'll finish up by talking about all of the ways that you'll be able to try out the Snyk platform for free on AWS to start seeing some of the value in Snyk's cloud native application security platform. So first, just to start, of course, it is pronounced Snyk, as in a pair of sneakers or in sneaking around. Tends to be the first question that we get. And Snyk is a platform for developer-first cloud-native application security. What do we really mean when we say that? And I think it comes back to this idea that we are now at, maybe the end, maybe the beginning, maybe the middle of a transition, depending on sort of how you think about it, from this sort of pre-cloud IT model where you had applications and then you had the stack, and the stack was sort of static, right? It didn't tend to change. It was centralized. It was managed by a separate sort of operations group, and it involved physical infrastructure, right? It typically involved a data center and hardware and networking and literally cables plugged into switches and servers, and things like that. And what that ultimately led to was this idea that, there's a very slow deployment model, right? You would typically deploy applications every few months. They would need to be customized for that stack you were building them on. And then the management team ultimately was sort of separate, right, from that conversation about building applications. It was very much a build it, throw it over the fence, and deploy it onto that central IT stack. And somewhere in between, security is going to come along and talk about, what are the vulnerabilities here, run those scanners, bring it back to the development team. But out of context, too late in the process, and ultimately without the real context that or actionable advice that those developers need to make improvements, right, in those applications. Fast forward to today, and that model looks very different. What constitutes an application has really changed due to obviously the impact of cloud, but also things like agile development and DevOps. And what you see now is that there are far more areas of responsibility for developers. So in the previous world, developers might have focused on building your application code, your sort of proprietary business logic in the application, maybe choosing a few open source libraries that application depended on, and then everything else from there down, all of the centralized IT applications, the servers, the networking, et cetera, kind of belong to that IT world. And that's really changed now, where you have much more responsibility for developers. They're not only choosing those open source libraries at the application level, but they're also defining the containers that those applications run inside. So that is really at the operating system level, choosing the Linux packages that those containers or those applications need to rely on, putting all of that together in a container, but then deploying that to some kind of cloud infrastructure. How is that infrastructure configured? Well, it's in code, right? It's in CloudFormation templates, it's in YAML files. And increasingly, those config files are living in the same repositories along with the application itself, along with maybe the Docker file, with everything else that's needed to build the app or the service. So what you end up with is this model where previously, problems or issues, whether those are vulnerabilities or other kinds of issues that might need to be remediated in production, are no longer dealt with by that operational IT staff, right? Those are developer problems, right? Because they are code changes that need to be made, as opposed to physical infrastructure issues that need to be remediated. And along the way, you've got things like DevOps services and pipelines and orchestration and automation that's sort of allowing all of this to really move at kind of lightning speed, or as we like to say, kind of the speed of DevOps. That relies on the cloud, and it relies on applications being orchestrated and architected in a very sort of cloud native way. But that also involves new kinds of risks, right? And so we like to think about the modern application as involving these sort of 4 levels of concern. When you think about what are the potential sources of vulnerabilities in the service that I'm building. And this kind of piece of the iceberg above the waterline, as we like to say, is good old classic proprietary code, right? There's still a good amount of that in every application. But that code isn't necessarily being scanned in the context that developers need it, and certainly not with all of the prioritization mechanisms in place that the cloud deployment can ultimately provide. So even though that proprietary code is a smaller piece of the pie, developers really lack a solution that enables them to understand what are the security implications, what are the risks associated with the code I'm building in my application when it's in my part of the SDLC and when I can actually do something about it. But then open source adds an entire new layer of vulnerability, right? So those developers aren't just writing proprietary logic. They're also going out and saying, I need to pick libraries of functionality that enable me to deploy faster, right? Because now we're no longer deploying every few months. We're deploying every few minutes or seconds. That means that I can't afford to spend weeks building a piece of functionality that is essentially undifferentiated heavy lifting, right? I'm going to go out, find an open source library that does that, make that one of my dependencies of my application that gets pulled in at build time. The problem, though, right, is that each of those open source libraries also has their own dependencies that they rely on, and so on and so on. And so you end up with these massive open source dependency graphs that are full of what are called indirect dependencies. That means, you don't necessarily have visibility as the developer into what is every piece of code, what is every library, what is in the bill of materials of my application. That's all being brought in when that's being built by an automated process. So again, major risk there from the developer perspective that's not necessarily covered or mitigated by existing security tools. Containers, as we mentioned, add another new source of vulnerability, and that visibility problem is there as well, because I might know the base image or the parent image, the base OS that my container is built around, but I almost certainly don't know every one of the hundreds of Linux packages that are inherited from those public sources, right? So I might go out and choose an ecosystem, write a Docker file that goes out and grabs the public image, but I don't necessarily know which image that one is based on, and so forth. So it's almost the same technology that enables containers to provide such rapid software development is precisely what gives them allows you to inherit so much risk, right? Because you're pulling in everything from that parent image without necessarily understanding what's inside of it. And then that final layer is the infrastructure as code. And these, again, are those YAML files, the Kubernetes configs, the CloudFormation templates that are configuring and driving how those containers are orchestrated out in the cloud. And this is an important layer for a few different reasons. As I mentioned, it's now developers who are increasingly responsible for writing this code. But that can entail additional risk, because you could do something like create an S3 bucket that's not encrypted, or that has wide open, ingress from the world. Maybe I'm leaving an SSH port open on a security group or something like that. So not only are there potential risks associated with misconfiguration of infrastructure as code, and in fact, a lot of the defaults in some of those IAC frameworks, including CloudFormation, are actually insecure. So if you just deploy without including a particular bit of configuration, you'll get the insecure option versus the secure one. And again, developers aren't necessarily experts in cloud infrastructure, even though they're being asked to write these config files and have them live in the same repository along with that application code. But the other piece that makes infrastructure as code interesting is that misconfiguration of the cloud infrastructure can actually exacerbate or increase the blast radius of vulnerabilities inside the container or inside the application. Because most vulnerabilities have what are called vulnerable conditions or attack vectors, right? These are kind of prerequisites that allow that vulnerability to be exploited from the outside. And if you're configuring your workload in such a way that you're combining a vulnerable piece of code with the conditions that allow it to be exploited, all of a sudden you've got a much bigger risk. But you only know that if you have tooling and visibility that allows you to see the combination of the vulnerabilities in the application, in the container, and in the infrastructure together, and be able to visualize how those interact. So fundamentally, what you're looking at here is the Snyk platform as it exists today. So there are 4 products available via Snyk. We call them Snyk Code, which is a static analysis tool that allows developers to get visibility into vulnerabilities in their proprietary code. Snyk Open Source, which is a what's called a software composition analysis tool that's analyzing all of the open source packages in that dependency tree, including all of those indirect dependencies, showing which of them have known CVEs associated with them. Snyk Container is a container scanning tool, allowing developers to see what are the vulnerabilities associated with Linux dependencies that might be packaged inside that container. And then finally, Snyk Infrastructure as Code, which is looking at what are the known misconfigurations associated with those YAML and JSON configuration files that are living in my repository, and how might those exacerbate potential vulnerabilities within my application. What is Snyk doing, however, that is unique? Because there are a lot of other security tools on the market, right? There's SaaS scanners, and there's infrastructure scanners, and there's container scanners, etc. Really, it's 3 things that make Snyk stand apart, I think, from the rest of the pack. And first and foremost, I've already kind of mentioned this, that developer empowerment is key to everything we do. What that really means is understanding that developers now have a much bigger job than they had 5 or 10 years ago, are responsible for more levels of the stack. And developers also probably already have an existing tool chain that's enabling them to get their work done, right? To build it, to deploy it, to get it out into a pipeline. So one of Snyk's core values is we want to meet developers where they're already at. And that means being flexible about the technologies that we work with. That means having a robust API, command line tooling that allows any developer, regardless of what you're already working with, to make it easy and make it a downhill process to get that security intelligence earlier in the process when you can actually do something about it. Because that, fundamentally is what makes vulnerability remediation cheapest, is when you can actually get that information in front of the developer in their environment, right? Maybe something like an IDE or their local command line while they're actually making decisions about what goes into that application. The second piece, though, is it's not enough to just shift left. You can't take a piece of security intelligence that's maybe designed for an auditor or for a risk analyst to look at later on in the process and give that to a developer and assume that that's going to lead to cheaper and easier fixes. Because fundamentally, it's a different kind of information that needs to be consumed. What a developer needs to see is what is the action that I can take? What is the recommended remediation that allows me to get this into my application, pass the build, get it out into production? So what a developer fundamentally wants is, I don't so much care about identifying the problem. What I care about is identifying the solution and automating that fix as much as possible. So everything Snyk does is built around the concept of getting the fix in the developer's hands by making an intelligent and educated fix recommendation that identifies an action they can take to move the ball forward and get that remediated code back out into production. And then finally, the last layer to everything Snyk does is focusing on having the best sources of security expertise in the industry. And this starts with what we call Snyk Intel, which is our vulnerability database that starts with a number of public sources, but is then hand curated so that we're eliminating a lot of the duplicates, the false positives, the noise that are typically associated with some of those public databases. We then augment that with proprietary security research that we do on things like exploit maturity, on social trends that might indicate new exploits are in progress, on those vulnerable conditions and reachability of vulnerabilities that might change the way they're prioritized for some applications versus others. And then we bundle all of that in to the Snyk product to allow developers to immediately see, okay, these are the highest priority vulnerabilities in the context of my application. And then the final layer to that is what we call deep code AI. And that is our machine learning engine that is constantly learning about new vulnerabilities. It is able to look at the world's output of open source code, all of the known vulnerabilities associated with those code bases, and then intelligently determine what constitutes maybe a SQL injection data flow or a cross-site scripting data flow, and bring, again, all of that back to the developer when the information is most useful, which is in their environment, and with the actual remediation advice they need to make more intelligent decisions while they're building their applications. And so again, Snyk can fit in across that SDLC, and I'm going to show a few different examples of this as we get into the demo portion. But all the way from the coding phase, when that developer is inside their IDE on their local command line, they can be identifying vulnerabilities almost literally as they're being written, along with not just the identification, but also the fix advice directly in line. We can also integrate with things like a Git repository so that you can do code checks on code that's being merged in, for example, automated fixes against your code that's living in a Git repo. We have CI/CD plugins available so that you can block builds based on a custom security policy, apply those fixes in real time as that code's being built, proactively monitor that code once it's built, and get notifications that new vulnerabilities are available. And then finally, production level monitoring. So we can look at containers in a registry, for example, like ECR, containers in a running Kubernetes cluster like EKS, serverless functions like Lambda. And again, give you proactive monitoring and notifications as new vulnerabilities are found, always packaged together with, here's the actionable remediation, because our goal ultimately is to help you get that remediated code back into production as soon as possible. And this all fits in really nicely with AWS services, right? So whether you're using something like code commit to store your code, a variety of IDEs you might be interacting with, code pipeline to build that code and maybe deploy it out to something like EKS. Amazon Inspector recently has been integrated with Snyk's vulnerability database so that you can get intelligence from Snyk Intel through your use of Amazon Inspector. So we have a multitude of integrations with AWS services across that application lifestyle, which helps you secure those applications from the developer workstation all the way out into production, again, across those four areas of the Snyk platform: Snyk open source, Snyk container, Snyk code, and Snyk infrastructure as code. And again, for a bit of added context here, there's a mixture of integration that Snyk shares with both AWS as well as other industry-leading solutions across that SDLC. Just to expand on the previous graphic here, if we look at from source code editor through source control, through CI/CD, and finally into production, we have a number of both native integrations with things like Inspector, with things like AWS Code Pipeline, as well as our integrations into those runtime services like EKS, ECR, and Lambda as well. So we'll look at a couple of those today here in the demo. All right, so I think with that kind of top level overview, we're ready to dive right in. So I have actually deployed an application into AWS that I know has a vulnerability in it that is that is exploitable rather from the outside, something called a remote code execution vulnerability. The way I've deployed that application into AWS is actually to use our Snyk AWS Quick Start. So we have a number of AWS Quick Starts that are available that allow you to create AWS resources with Snyk security built in already. You can also use these quick starts to attach your existing workloads like EKS clusters to what we call the Snyk controller that allows you to monitor those clusters and the workloads in them in real time. You can do similar things with ECR and with Lambda as well. So I just simply went to this, AWS Quick Start page, went to the GitHub repository where I looked at kind of what that Quick Start does, and then was able to deploy that directly into my AWS account, which created for me an EKS cluster as well as an ECR registry to deploy my containers into. So that's basically what I'm working with here. I've got a single EKS cluster that's just named with, with today's date here. That has two deployments in it. And I'm actually working with a lamp stack application here. So I have two pods running in my cluster. One of those pods is running PHP. The other pod is running Nginx. So I've got an application tier and a web tier associated with pods here in this cluster that I've deployed. Now, the containers that cluster is pulling from are actually stored over in ECR. So I've got actually the two containers that I mentioned, one running Nginx, one running PHP, and I've got kind of a broken version and a fixed version here, and I'll show you the differences between those here in just a moment. But right now, I've actually got the broken or the vulnerable version of that container deployed out into the EKS cluster that I'm working with. So if I were to go ahead and load the page associated with the ingress to this EKS cluster, what I'm going to see is probably familiar to a number of you here. I've just got this Nginx kind of welcome page, right? So I have no outward indication that this represents a vulnerable application at all. In fact, I don't really have an indication of kind of what is behind it, right? I don't know that it's actually a PHP application that's driving this Nginx front end. I've crafted this, as I mentioned, specifically to be a vulnerable application. So I'm using a slightly out-of-date version of PHP to drive this application tier. The version that I'm using is actually PHP 7.3.9, which is about a 2-year-old version, and it happens to contain this vulnerability. So what we're looking at here is the Snyk vulnerability database, as I mentioned earlier. This is our hand-curated database of vulnerabilities that allows any developer to understand immediately kind of what is the risk associated with a particular issue, and ultimately what can I do about that if it's found in my applications. So I can see a few things about this vulnerability. First, I know that it affects PHP versions less than 7.3.11. So the version I'm using definitely qualifies. This is a 9.8 CVSS score, which makes it a critical vulnerability. And if I read through the description here, I see that the reason this is so critical is it actually allows remote code execution, right? That means from the outside, an attacker can run an exploit against an application that contains this vulnerability and execute their own code, right, to do kind of very bad things. I've also looked, and so I take this CVE identifier here, which is CVE 2019-11043, and I went out and looked for, what are any exploits that are associated with this issue. We've got some of those links here in the Snyk VulnDB as well, so you can look at all of the advisories and all of the various research that our teams have done around this issue. But what I found was a GitHub repo that basically says this is the exploit that's available for this particular CVE. Now, I didn't write this. I'm not associated with this author at all, but I did go ahead and clone this repository and used it to run it against that application that I've deployed into AWS. So what I'm going to do here is actually pause the sharing, I believe, on my browser and actually go over to my terminal. And what I'm going to do here is show you the running of this exploit. And I think this is going to pop up here in just a moment. So what I've done is I've run the utility from that GitHub repo that I mentioned, and I've run it against the public URL of the workload that I've deployed out into AWS, right? So I've got a little empty PHP script that's in here. And what this tool has done is basically queried that endpoint. It has recognized that, yes, this is a vulnerable version of PHP that it's targeted. And we were successfully able to execute a command remotely. So from the outside world on the internet, we were able to run a command against this workload and basically make arbitrary changes, right, to the pod that this is running on. So I'm getting concerned here as a developer, right? This is really enabling any attacker to do kind of nefarious bad things on my EKS cluster and ultimately within my AWS environment. Let me just switch back here to my browser and show this in even a little bit more relief here. I'll just pop back to this other window. So remember, we have this Nginx entry page here, but now that this has been exploited from the outside, and I've read this in the description here of the exploit, basically what this allows me to do is append any command I want using a query string variable, right? So I can just say, going back to my main page here, question mark, a equals, and I'm just going to say, hey, do bad stuff.sh, right? I'm not going to go into detail about what that is, but basically this is a script that runs a bunch of kubectl commands, and it defaces actually the page on the Nginx pod by sort of exploiting the vulnerability in PHP, going back in through the front end and replacing my home page with this defacement page, right? So again, though, that do bad stuff script really isn't interesting in and of itself. It's the exploit that allows that arbitrary command to be run on my cluster. So now I'm in a really bad place, right? Not only do I have a vulnerable workload, but an exploit has been run and it's actually defaced the web page that's being hosted on my EKS, right? What can I do about that at this point? This is really where Snyk comes in, and we can start the process of triaging this issue, attempting to identify and prioritize it, and getting back to the remediation. Now, I mentioned earlier, I deployed this EKS cluster using our Snyk EKS Quick Start. What this does is not only gives me an EKS cluster to work with, but it also installs what we call the Snyk controller. This is basically a service that runs on your cluster, and it provides continuous monitoring of the workloads or the container images that are declared by the workloads in EKS. So this is a integration with our Snyk container product. So we're scanning for vulnerabilities in the containers deployed by EKS. Now, you can do this in a few ways. You can use the quick start, as I mentioned. We also have a Helm chart available. So if you already have an EKS cluster or really any other Kubernetes, you can deploy the Helm chart directly and immediately start getting vulnerability results back from your existing workloads. So I'm going to jump over into my Snyk UI here. As I mentioned earlier, we have a number of integration points, right? Whether I want to secure applications at rest in source control, containers in a registry like ECR, we'll look at that in just a second, in my production environment, in my CI/CD pipeline, etc. So lots and lots of different ways to get value from Snyk. Because this is an application in Kubernetes and because I started with the quick start, I already have that configured. So it's a simple matter of saying I want to add projects from my Kubernetes cluster and identifying which those are, right? So as we can see, I've got now my Nginx pod and I've got my PHP pod that actually contains the vulnerability. I will go ahead and add those workloads, and those will end up on my projects page here in Snyk. So I'm just going to restrict this to workloads coming from Kubernetes. Now, as you can see, I've got some vulnerabilities here, right? I actually have a couple of issues in my Nginx pod. So if I were to look at these, I would see kind of the vulnerabilities associated with the Linux packages running on this container. So I've got some issues here in curl and in glibc and a couple of other things. But I'm actually not seeing anything here that is of huge concern, or at least not the level of concern that would lead to a potential defacement of a web page. But if we look a little bit deeper, I'm now actually going to pull up the result from that PHP pod, right? Because I know this is where the vulnerability originated. I've got more critical issues here, so it already looks like this might be the place where that issue is made clear. And, no surprise, right at the top of my list, what do I see? This out of bounds write issue in PHP 7.3, which, as we mentioned, is CVE 2019-11043. So Snyk has already identified this issue in my container, and it has shown me that this is actually the biggest priority in terms of what I should be looking at remediating in this workload. Why is it such a high priority? Well, if I look at the way Snyk's priority score is structured here, this is our contextual representation of all of the factors that go into this prioritization. So not only is this a critical vulnerability with what we saw earlier, a CVSS 9.8 severity rating, but also this has what is called a mature exploit. Meaning, as we saw before, there is published code available that attacks this vulnerability from the outside. So not only is this a critical severity issue in theory, it also has known packaged code that anyone can download, as we just saw, to conduct this attack. In addition, I can see that there are some prioritization mechanisms here that are related to how this particular workload was deployed. And this is a specific feature of the Kubernetes integration of Snyk container. I can see that we're prioritizing this vulnerability not just because of its CVSS score, because it has a mature exploit, because it has a fix available, which we'll get to in a moment, but also because I have misconfigured some of the parameters associated with the deployment that is actually configured this container to run in my cluster. And if I look at this page here, you can see Snyk is not only checking for vulnerabilities in the container, we are also looking at vulnerabilities within the configuration. So this is, again, that YAML file that I use to deploy the workload into my EKS cluster. I'm basically failing all of these checks here, right? I've got CPU and RAM limits not set. I'm not running as a non-root user. I have write access to the root file system. But most importantly, I'm running in privileged mode. This is, if you take one thing away from this talk, is that privileged mode is very bad. Because you'll remember that what we did was exploited a vulnerability on the underlying application tier in PHP that we were then able to use to deface the web page running on the web tier, which was on the Nginx pod. So we actually were able to jump from one pod to another. And the reason we could do that is that this pod that's running PHP is actually in privileged mode, meaning it had access to the Kubernetes API itself and could make changes in other pods, which is ultimately what we did here to attack and deface this application. And again, Snyk is taking that into account when we're computing this priority score, right? So the context of my configuration, in addition to the vulnerability and the severity of it on the container, is what results in this high priority score that is drawing my attention to it as a developer. All right, so we understand what happened here, right? We exploited an issue in the application tier that allowed us to, through privileged mode, jump into the web tier and ultimately, deface our web page. Now, what can I do about it, right, is obviously the next question. And this is really where I think Snyk provides a lot of value, because there are other tools that can provide, scanning of containers, right, and scanning of infrastructure. But what Snyk really enables you to do is understand what the remediations are associated with those issues. So I'm going to do two things here. I'm actually going to look at potential earlier ways I could have identified that vulnerability. One way I could do that, as opposed to scanning only my workloads that are in EKS, is I could actually scan those containers in the registry, right? So maybe before they've been deployed to a Kubernetes cluster, I can scan them after they've been built as they're sitting in something like ECR. That's a simple matter, again, of going to add project. I've already integrated my Snyk account with ECR. And so I see, those three images that we've added here, all pulling directly out of Amazon, right? So I can very easily kind of add those to my Snyk UI here. But we can even go further left than that. If you remember kind of looking at the way Snyk integrates across that SDLC, we don't necessarily just have to play here in production, right, in the registry or in the EKS cluster. We can actually identify vulnerabilities all the way back here in either the source code editor, the IDE, or inside the Git environment, right? So what I'm going to do here is actually look at the Git repo that I started with that deployed all of these services out into Kubernetes. And if I do that, I see that Snyk was able to find some of these issues way back here just by scanning the code in my Git repo, right? And we've identified not only issues with the container by scanning the Docker file itself, we've also identified issues in the Kubernetes deployment using our infrastructure as code tool. So I'll look at PHP first, or rather I'll look at the Docker file first. As you can see, we've identified the base image that I'm using. Remember, that's that PHP 7.3.9 that contains the vulnerability. We know that that's coming from ultimately Debian Linux base OS. And if I then look at, I can see the vulnerabilities here, obviously, but most importantly for me as a developer, I can also see Snyk's recommendations for upgrades to my base image. So I can see that if I were to move from this PHP 7.3.9, which has 11 critical vulnerabilities associated with it, and do something like maybe a PHP 7.4 or even an 8.1, if I wanted to go to really the bleeding edge, I can reduce that critical count from 11 down to just 2, right? By making a single change in my Docker file. And Snyk actually enables me to automate that fix, right? So all I have to do is say, open a fix PR that's going to change the line in my Docker file that specifies my base image, right? So the from line at the very top is going to be changed from the PHP 7.3.9 to 7.4.24 automatically just by clicking the button. I can even turn on automated fix PRs so that anytime Snyk knows there's an upgrade to my base image available that might remediate critical vulnerabilities, that can just be waiting for me in my Git environment next time I sign in. So again, making it as easy as possible from the developer perspective to make it a downhill process to get more intelligence about security earlier in the process. So that covers one of the two issues that were in our workload, right? We had that vulnerable version of PHP. I've remediated that by making that fix PR. The second issue came in because of the way we deployed it, right? Because if we just had the vulnerability, well, that's bad in and of itself. It wouldn't have had the same risk profile or blast radius unless it had the deployment had also been misconfigured, right? So what Snyk is able to do here is look at my YAML file that was used to deploy that out into AWS and run an infrastructure as code scan on that as it sits at rest in the Git environment. So before that deployment has happened, Snyk can run against the IAC file itself, which in this case is a Kubernetes template, but it could also be something like a Helm chart, could be a Terraform TF file, could also be an AWS CloudFormation template itself to look at some of those infrastructure misconfigurations. And what do I see? Lo and behold, the one high severity finding in this file is that I have privileged true in my security context, right? So this is what allowed the attacker, me, to not only run arbitrary code on the application pod, but then jump via the privileged mode back to the web pod and ultimately deface the web page there. If I look at what Snyk tells me, it gives me some basic information here, right? I know that the container is running in privileged mode. I can see the impact of it, which we just saw, which is, hey, I can potentially modify anything on the underlying host, including other pods running on the cluster. And then ultimately, we have the resolution here, right? Which is I need to set that security context privilege attribute ultimately to false to remediate that issue. So I'm just quickly going to show kind of the effect of those remediations. And let me switch one more time. I'm going to switch screens to my text editor here to just show you what I've done to kind of remediate. And if I pull up my Sublime text, what you'll be able to see is here's the, first of all, that deploy PHP YAML file that we were looking at. So I've been able to change security context here. Originally, it was true. And I went ahead and implemented the fix that Snyk suggested. So now we no longer have that security context line. I've also changed a number of the other recommendations or made changes based on those. For example, adding run as non-root, read-only write file system, or read-only root file system, and then adding a run as user so it no longer runs as root. So this is now, a much more secure workload, as will later be seen when we go back into Snyk. The other change I made over here on the Docker file is rather than the 7.3.9 base image, I'm starting with a PHP 7.4, which is going to pull the more up-to-date version and ensure that it no longer has that remote code execution vulnerability available. All right, one more switch back to my browser here, and we will just show how all of that works out once we get back into Snyk. So now I've got not only the broken version of this application, but I also onboarded the fixed version, right? So if I look here at the version that I, let's just say in the background, I ran a kubectl command, rebuilt the image, pushed it or applied it rather up to that EKS cluster. I now am seeing, because of those changes that I made, a pass for all of these configuration variables. So I no longer am subject to that privileged access that allowed me to jump between pods. And I am no longer seeing the PHP vulnerability here with that remote code execution. In fact, I've dropped, as Snyk promised I would, from the remediation advice, from those 11 critical vulnerabilities to just these 2, which have much lower priority scores as well, because they don't have mature exploits available and they are not affected by the misconfigurations, right, that we would have otherwise seen before we made those changes. All right, so that kind of takes us through our live hack. We have broken our workload, but ultimately brought it back to life. And if I were then to reload, the page here, I would see that Nginx page. This is still the old URL, but I would then see the original page here before that defacement got made. So I think this illustrates some of the value that Snyk is able to provide, not only by scanning those production workloads as they exist in the EKS cluster, but also by being able to jump back and integrate earlier in the process, whether that's in the container registry, in the CI/CD pipeline, for example. So I could do things like block these workloads from being deployed when those vulnerabilities are found by scanning the infrastructure as code at rest, by scanning the containers before they actually get pushed, and then ultimately to bring this back into the developer hands by integrating with something like their source control repository, or even directly in the IDE, and able to recognize a lot of these vulnerabilities as they're being integrated into the applications to begin with. All right, all of that said, I think that wraps up our demo here, and I'm going to hand things over for just a moment to David Lugo on our Snyk partnerships team to talk a little bit more about how Snyk and AWS can help organizations develop fast and stay secure. You out there, David?
Thanks so much, Clinton, and what a phenomenal demo you were able to provide folks here. I think if we were to look at Snyk as a company, just the wider company, today we're enabling over 3 million developers with the type of features you all saw during Clinton's demo. We have over 900 employees that are working tirelessly to make sure that in this new modern era, we're building applications securely as we're building them without these, testing gates that create sort of a constraint on development teams and security teams, make it difficult to scale and remediate these vulnerabilities, as we're seeing more and more coming from microservices and these modern forms of applications. We've raised all of this money because we, in the industry, I think folks have seen that the direction that we're taking security, about empowering the developers to take remediation into their own hands, to get actionable remediation advice to make these changes, is the way the entire industry is going. And we have over 1,000, happy customers that are taking advantage of at least one of the products in our portfolio today that Clinton mentioned. As far as our relationship with AWS recognizes us as a strategic security partner within their AWS partner network, and have given us an advanced technology partner designation to work very closely alongside them with many of their enterprise customers to ensure that those customers are building applications securely. We've been validated through very rigorous technical validations by AWS across all of our integrations on the SDLC to make sure that we're implemented easily, securely when people are using Snyk on AWS. And as a result, we've earned DevOps and security competencies and service ready designations for Amazon Linux 2, for AWS Lambda. And just to make your life easier, even during the purchasing process, we partner very closely with AWS as an AWS Marketplace seller to make Snyk available to you through the AWS Marketplace in case you like to purchase by consolidating your invoicing mechanisms, purchasing using your existing billing mechanisms with AWS, and in some cases, even using purchases like Snyk on the AWS marketplace in order to burn down your spending commitments with AWS, sometimes called EDP, Enterprise Discount Program. Most importantly, you can get started with Snyk today. You can try us out for free. You can sign up for a free Snyk account and start using us within your environment. And like Clinton mentioned, taking control of these quick starts we've built for you, taking advantage of those easy implementations that we've built out, these automated reference deployments, make it easy for you to deploy Snyk Container, Snyk Open Source, and other Snyk products onto your AWS environment without messy configuration files. I think we can move on to the next slide here, Clinton. These AWS quick starts today, we have 3 available and more coming soon in 2022. Today, you can deploy Snyk Container to scan your ECR registry. You can deploy Snyk Controller to monitor your EKS clusters. You can even deploy Snyk Serverless for CI/CD to ensure that you're securing your applications, finding and fixing potential vulnerabilities and open source dependencies, even in your Lambda functions. And like I said, it's very easy to procure Snyk on the AWS marketplace. Basically 4 easy steps. As long as you can negotiate some custom pricing with a Snyk representative, we'll be able to build that offer for you on the AWS marketplace and give you a link to navigate to. Once you click on that link, you are immediately invoiced using your existing billing mechanisms with AWS, taking a procurement lifecycle that can sometimes take up to a month and bringing it down to just about a couple of days, cutting a lot of red tape and making your life easier, even when just purchasing Snyk. So Clinton, I don't know if you want to jump in here as well, but like I said, free to set up an account. You can start with Snyk today. We've placed a link here in the chat in case you'd like to start today with Snyk. You can just copy that link, put it in your browser, sign up, import your GitHub repo, and start scanning immediately. You can do the same if you want to try any of our quick starts. If you want to try our native integration into AWS Code Pipeline, bringing the entire Snyk experience directly into AWS's CI/CD service without having to leave the AWS console, or any of the many workshops that we've built alongside AWS to help you get hands-on experience using our product when building workloads on AWS services.
All right. Thank you so much, David, for that overview of the partnership. We are so excited to be working with AWS through some of these exclusive integrations. We're very excited that the integration with AWS Inspector was announced last week, which just adds to the number of of these integrations that are utilizing Snyk's vulnerability intelligence in a lot of these household names in the industry. So we expect that partnership to continue to grow. But most importantly, I think we are focused on enabling every developer on the planet to have access to better security intelligence earlier in the SDLC with the right context that they need to make those remediations when it counts, which is in the development process. So hopefully I've shown you a little bit of those capabilities today. If there are any additional questions, we would be happy to address those. Also, just be happy to jump on a call, walk you through some of those advanced features of Snyk once you've been able to use the free version to get your hands dirty and started to see some of the value that we can provide. With that, I don't know if we had any questions come in on the Q&A, but I think I can send it back over to Cody here.
Yeah, so we did actually have a couple questions come in, so I'm gonna throw those at you now. So the first one says, what if a customer is running their repository in a private VPC, and how do you connect into a private VPC?
Yeah, great question. So Snyk is a SaaS service, but we have a number of connectors that enable you to integrate your private workloads as well. So we have a tool called a broker, for example, that handles by proxying the connection between Snyk and your private resources in the VPC so that you don't have to poke any holes in the firewall, don't have to add ingress rules or anything like that. It basically turns it kind of into an outbound connection. That enables you to get the best of both worlds of keeping all of your repositories, your container registries, your Kubernetes workloads inside that private environment, but then connecting back to Snyk so those scans are run in your perimeter, but Snyk still is able to get that vulnerability data and get the fixes out to your developers as soon as possible. So we do definitely have solutions there.
And that ties pretty well into this next question, actually. So it asks, How is Sneak's vulnerability database updated? Is it Sneak researchers or a third-party source?
Yeah, we are very proud of our vulnerability database, as we can see by the fact that Amazon AWS is now a customer as well, in addition to again a number of other big names. And they wouldn't be doing business with us if they didn't see the value in our proprietary research. So we do start with public data sources that are available, but are frankly full of a lot of false positives and noise, and are very difficult to kind of parse through. So we start by hand curating all of those sources before they make it into our database, which immediately, increases the signal to noise ratio there. But we also add a lot of proprietary research on things that you won't find in the NVD, for example, things like exploit maturity information. So you can know that, yes, there is prepackaged code that attacks this vulnerability, right? The public databases don't tend to make that distinction, certainly don't use it in a way that enables you to prioritize. What are the vulnerable conditions associated with particular vulnerabilities, and do those exist in your applications? Is there social media chatter, right, that might indicate that a vulnerability is likely to be exploited soon, even though we're not aware of any proof of concepts available? So all of that research is constant and ongoing, and it's integrated directly into the Snyk product on a daily basis. That's also what enables us to notify you as new vulnerabilities are found. So you don't constantly have to keep doing scans in Snyk. You onboard those containers from ECR, for example. If there's a new vulnerability found in any of those dependencies, whether it's tomorrow or a year from now, you'll get that notification, and we can integrate with a webhook to other systems to create tickets, to notify the right people, to make sure that those actions are being taken. So the heart of Snyk is that vulnerability database and the in-house research that we're doing to augment that and to help you prioritize and know the best, most effective ways to spend your remediation budget to reduce risk.
Awesome. And it looks like we had one final question that ties a little bit into that as well. But they ask, does Snyk integrate with centralized vulnerability management solutions like Kina or Brinka?
Yeah, absolutely. So we do have a number of VMS integrations that are available. Kena and Brinka are both on the list, as well as things like Fortify SSC. I also mentioned that AWS Inspector now has that first-party integration with Snyk as well. But effectively, we don't want to be the bottleneck, right, to developers getting security intelligence. So if you already have a VMS or a SIM solution that you like, that's great. We interoperate with those tools. You can take Snyk security data in machine readable format as an API call result or as a JSON file that is exported by our CLI, consume that with another service. So we are very plugged into the communities developing around interoperable standards for things like SBOM, software bill of materials, for example, and are really leading the charge to make sure vulnerability data is as open source as possible, because we don't want the lack of an integration to be the barrier that prevents your developers from getting the right security intelligence when they can make better decisions about what goes into their applications.
Outstanding. Well, that concludes the questions that we received today. So real quick, I just want to give a reminder that this session is recorded. So you'll receive an email after the webinar concludes with a link to access the on-demand. If you don't receive that email, just check your spam folder. So on to the 4 winners of our $25 Amazon gift card drawing. Our first winner is Ron B. Our second winner is Yoonli Q. Our third winner is Bilal A. And our fourth winner is Sharon B. So congratulations to the 4 of you. Keep an eye on your inbox and your spam folder to claim your Amazon gift card. Clinton, thank you so much for taking the time to put together this program, this presentation, the demo. Do you have any final remarks before I officially cut us off for the day?
I would just say, if you're at all interested in securing, modern applications, please do give Snyk a try. We are very committed to our freemium product, making sure that any developer who's working on maybe a personal project or an open source community has access to that vulnerability data, because ultimately that just makes everyone more secure. If you are interested in having any conversations, we're available. But look, I'm an engineer. I assume most people on the call today are engineers. And so you want to get your hands dirty with technology, just head on over to snyk.io, grab the CLI, integrate with the Git repo, and start seeing the value. Maybe remediate a few vulnerabilities, because they're probably there hiding in your code. If you're anything like me, that anxiety keeps you up at night, and we ultimately want to make your life easier.
Awesome. Well, thank you, Clinton, and thank you, David, for your remarks as well. We can't forget you. I'd also like to thank Snyk for sponsoring today's presentation, and my final thanks goes to you, our audience, for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great rest of your day.
Thanks, everybody.